Okay, girls, this video is going through just the basics of functions, so what a function is. So I'm going to start from the very beginning so that, in case you need to go back to the beginning, you can revise it. Okay, so first we've got the idea of functions and relations. Now, it sounds very official, but it's really just any points on the Cartesian plane. That's a relation. So it could just be literally just a set of points like this. That could be a relation. Or it could be a line like this one, or any kind of curve. So anything at all that you can draw on a XY plane is technically a relation. Now, as with this first line, it could be defined by an equation, y equals x plus 2, or for instance this curve here, x equals y squared minus 1. A relation can also be made up of random points or region on the Cartesian plane, so like this entire region. So every point in this rectangle is part of this relation. However, a function is a type of relation. This word here should be functions, a special type of relation in which no two points have the same x-coordinate. So every x-coordinate corresponds to only y-coordinate. So for instance, when x is -1 here, that only corresponds to this y value of about 2. So there's no other, it doesn't pass x equals -1 again. When x is 2, it only corresponds to this y-coordinate there of about -4. Okay, it doesn't work the other way though. For instance, this y-coordinate -2 corresponds to this x-coordinate of about, say, 3/4, but it also corresponds to this x-coordinate of about 2.5, let's say. So it doesn't go the other way. Y-coordinates might correspond to 2 or more x-coordinates. Actually, it also corresponds to this one over here. So about -2.5. But it's only that x-coordinates correspond to only one y-coordinate. Now back here, with this relation, that wasn't true. So for instance, when x was 0, that corresponded to this y-coordinate and the one down here. Therefore, that's why this is not a function. For instance, back here, so to check if a relation is a function, we can check if there are any vertical straight lines that cut the curve more than once. If there are, then the relation is not a function. If I drew a vertical straight line, I only ever hit the curve once. If I draw it here, I only hit it once. If I draw it here, I only hit it once. Therefore, this is a function. But back here, if I draw a vertical straight line, here and here, I hit it twice. Therefore, it's a relation. If I can do that even just once with a vertical straight line, if I can hit it more than once, then it's a relation but not a function. For y equals x plus 2, no matter where I draw my vertical lines, I only ever hit it once. Therefore, this line is also a function. If we only have a set of ordered pairs that are not graphed, we just have to check that there are no pairs with the same x value but a different y value. I'll show you an example of that. So which of these are functions? Let's look at A. Hopefully you can see clearly that if I were to draw a vertical lines, I hit the function more than once. So in fact, it's not a function, it's a relation, so this is not a function. This parabola over here, no matter where I draw my vertical lines, I only hit the graph once. Therefore, this is a function. For question C, these points here. Okay, So 0 doesn't occur in the x-coordinates, doesn't occur again in either of these points, so that's fine. 5 doesn't occur again, -1 doesn't occur again, and 4 doesn't occur again. So because there are no points with the same x value but different y value, I know that if I graphed them, it would pass the vertical line test. So therefore C, the points in C create a function. In D, have a look at these, this x-coordinate is the same as this x-coordinate. So if I were to graph those points, at x is 4, I'd get a point at about 2 and 8. So this point here would be here. This point here would be directly above it at 8. Therefore, it wouldn't pass the vertical line test because I hit him twice. Therefore, this is not a function, so it's just a relation. So we can say no, or it's just a relation. So now I didn't have to draw it in that example. I just had to look through the points and see that this point and this point have the same x-coordinates but different y-coordinates, and therefore it's not a function. But I drew a diagram to help explain why that's so. Okay, so this now corresponds to exercise 2A in your textbook. I would do a few of those questions just to make sure you understand the concepts here.